What is common among what you have seen?
Hello, future scientists of 7th grade. How are you today? I hope you are all doing good. I am Miss Algin M. Samson, but you can call me Miss A, your friendly virtual mentor. After this lesson, you must be able to, first, identify the characteristics and properties of light. Second, explain the color and intensity of light. And lastly, appreciate the importance of light by citing real-life situations where light is used. Inhale, exhale, and get ready as we journey the Science 7 universe.
Before we proceed, I want you to prepare the following: a science notebook and a pen. If you have a copy of your DepEd Science 7 Learners material, get and prepare it too.
I will give you 10 seconds to prepare. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time's up! Now that you're ready, how about we play a quick game? Guess a word which can be associated to the 4 loops that will be shown to you. You will be given 10 seconds to answer. I think you're ready. Let's begin!
4 loops, 1 word.
Time's up! If you answered ice, good job! Next. Time's up! If you answered light, you're right. Now, for the last round, let's begin. Time's up! If you answered spectrum, you must be a genius! That's right! Let me repeat the answers. Ice, light, and spectrum. In order for us to see and appreciate the world, we should use our eyes to perceive light and see the visible colors of spectrum wheel. Did you see that? Quick fact, did you know that the speed of light is the fastest thing in the whole wide universe? In a vacuum area, it can travel around 186,000 miles per second or 300,000 kilometers per second. Whoa! Another big fact, did you know that famous figures like Sir Isaac Newton and Christian Huygens studied about light during the 17th century?
Another famous figure, James Clerk Maxwell, made a more detailed explanation on light with his classical theory on electromagnetic radiation in the 19th century. Have you experienced a blacked out in your barangay? What would life be like without light? How would you describe it? Correct! It's dark. And darkness means the absence of light. But what do we really know about light?
If you may recall, light was introduced when you had your discussion on waves. Waves have basic characteristics such as amplitude, wavelength, and frequency. Today, we are going to focus our curiosity on visible light, the most familiar form of electromagnetic waves since it is a part of the electromagnetic spectrum that human eyes can detect. Just like waves, light has its basic characteristics too. Light is a form of energy. It provided the energy both plants and animals need. Also, energy can be transferred from one point to another point either by particle motion or wave motion. Intensity of light is affected by the wavelength and frequency of light wave. And the frequency and wavelength of light wave determine the color of light. Let us acquaint ourselves with the spectrum of colors in this activity that you can do at home. Just follow the procedures.
Now, we will make a spectrum wheel, and we will call this activity Colors of Light, Colors of Life. Prepare the following materials. Color Spectrum Wheel Pattern. You may download the pattern on the link provided. It would be better to print it on a vellum board, but if you don't have that, just prepare a cardboard and then paste the pattern to make it sturdy. Pair of scissors, cutter, and split pin. First, cut the two art files that make up the wheel. Next, completely cut out and remove the two small windows on the wheel. Then, make a hole using a cutter at the center of the two wheels, and then put them together on top of the other using a split pin. But make sure that they should be free to rotate relative to each other. When you see a region of the color spectrum show up in the open window and the wavelength, frequency, and energy that corresponds to that region showing up under the flops, then you know that you have done it right.
Here is the finished output. A spectrum wheel looks like this. I highly encourage you to try doing it at home. Again, you may download the spectrum wheel pattern on the link below. Now, let us try out our color spectrum wheel by positioning the innermost part of the flaps on color spectrum. This will simultaneously position the other flaps to frequency, wavelength, and energy. For the activity proper, turn the upper wheel and observe the combinations of colors. Then, tell me the frequency, wavelength, and energy of the color that will pop out in the screen. Let me try the first one for you. Green has a frequency of 566 terahertz, a wavelength of 530 nanometers, and an energy of 2.34 electron volts. Now, it's your turn. Write your answers on your science notebook. Ready? Let's do this! At this moment, observe the answers that you have written. Which color registers the highest frequency and shortest wavelength?
You're right! In the spectrum wheel, violet has the highest frequency with 744 terahertz and shortest wavelength at 400 nanometers, and violet waves carry the most energy.
How about the color that has the lowest frequency and longest wavelength?
Exactly! Red has the lowest frequency with 422 terahertz and longest wavelength at 700 nanometers. Red waves carry the lowest energy. With your observations using the spectrum wheel, explain the relationship of frequency, wavelength, and energy.
Alright, let's find out if your answer is correct. To find out if your answer is correct, let's listen to a notable science teacher here in Tarlac City.
Violet has the highest frequency, ranges from 668 to 789 terahertz, and shortest wavelength ranges from 380 to 450 nanometers. Violet waves carry the most of the energy. Red has the lowest frequency, ranges from 400 to 484 terahertz, and longest wavelength ranges from 620 to 750 nanometers. Red waves carry the lowest energy. Always remember that the wave with highest frequency has the highest amount of energy but shortest wavelength.
Did you get that right? I hope you did. Every time I look around, I feel fascinated by the various colors our world has. It feels thrilling to combine colors, doesn't it? Let us combine colors now.
Let us perform an experiment using flashlights and plastic filters. Observe what colors are produced as we project these flashlights covered with different colors on the screen.
I have 3 questions for you. Take note that I will only give you 5 seconds to answer each question. Write your answers on your notebook. Are you ready?
What color did you see as the flashlight with green plastic filter is reflected on the screen? Did you answer green? Well and good. You're correct.
What color do you see as the flashlight with blue plastic filter is reflected on the screen? If your answer is blue, way to go, you're correct! What color do you see as the flashlight with red plastic filter is reflected on the screen? If your answer here is red, wonderful! You're right! This time, let us mix the colors. Again, I have questions for you and I will only be giving you 5 seconds to answer. Write your answers on your notebook. Let's begin. What color do you think will result from combining blue and green? Did you answer blue-green? You're correct! Blue-green is also known as cyan. Shall we try blue and red? What is your answer? If you answered purple or violet, I understand because that is usually a misconception. But let us correct that today.
The resulting color is actually magenta. Magenta is defined as purplish red or reddish purple located exactly midway between red and blue.
Again, the answer is magenta. If you answered red-violet, that is acceptable. Let's continue. How about when we combine red and green? What is the resulting color? Of course, that would be yellow. Nice going. How about when we combine 3 colors? Red plus green plus blue. What do you think is the answer? Did you ever think it's white? Because it is! The answer is white. Quite a surprise, right? It is quite interesting how colors change when they are combined, right? Have you ever wondered why clothing stores rarely use blue light bulb inside their stores?
This is because blue light offers higher energy and frequency because of its shorter wavelength, making the store having hotter vibe. Therefore, white light is preferred.
Why do traffic lights need to be red, yellow, and green?
It is because red, yellow, and green have the longest wavelength compared to other colors. Since longer wavelength can travel for longer distance, the colors with longest wavelengths are picked for signals.
Red was chosen for stop since most people relate it with something potentially serious.
It also has the longest wavelength on the color spectrum and can be seen from greater distances, so it serves as a warning signal to begin slowing down sooner.
Green, on the other hand, is calming. It was chosen to signal go as it contrasts well with red and is highly visible too without being harsh or distracting. Now, I will give you something to find out on your own. As you can see, the sky is blue.
Why is the sky blue? Write your discovery in your science notebook.
I would also like you to cite 3 real-life situations where the importance of light is evident. I'm sure you'll do well. Thank you for discovering light with me, our dear future scientist. I am Miss A, your friendly virtual mentor. Until our next discovery, bye!
Do you now see light in a different light?